welcome to this lesson on parallel lines. This is in our Properties of Geometric Figures series. This is a bit of a revision lesson for most of you, so let's get stuck in. So a couple of things to be thinking about. So we have parallel lines. These are lines that are going to follow the same trajectory, go in the same general direction, and they will never actually cross each other because they will never get close enough to do that because they're the same width apart the whole way down. Now, when we're dealing with parallel lines, we will often have a third line going across them that we call a transversal, and this creates a whole bunch of different types of angles that we use to prove whether things are parallel or not. So to get us started, we're going to do a couple of little dot points. Our first one there is about the parallel lines themselves. So parallel lines never meet. So that's what I said before. They will stay the same width apart regardless of where you are in those parallel lines. Okay, so the other thing to know about parallel lines is we will often use some arrows to demonstrate or display that the lines are parallel. Okay, so that's parallel lines in a nutshell. And the other thing we need to think about is this third line, this transversal line. Alright, so transversal line. And what it does, it is crosses those two parallel lines. Okay, or you can cross three parallel lines, four, so it's two or more parallel lines. Right, so it's a line in and of itself that can cross two or more other lines. Okay, now once they have been across those other lines, they then form special angles that we can use to test for whether or not lines are parallel. Okay, and we can use these as a test to see if they're not parallel as well. So what we're going to have a look at is the three big tests that we do use in terms of parallel lines. And there we go. We've got the top two there that you can see pretty easily. Now here in that those first two diagrams, in that first row of cells there in the table, we have some non-parallel lines and we have some parallel lines. Now, these angles here, these angles here, these are what we call corresponding angles. Okay, these corresponding angles in a parallel set of lines, they will be equal. In a non-parallel set of lines, they are not equal. Now, they are called corresponding angles because they sit in the same place in relation to the lines. So you can see that the angle here, this little dot, and this little x, they sit in the same place in relation to the other two lines. Okay, same with the two dots in the parallel lines. They are corresponding, so they stay in the corresponding space. Now, if the lines are parallel, so if the lines are parallel, these angles will be equal. And you can see there that is signified, or in the diagram, it is signified by the two dots in the parallel line. So that means those angles are the same. Whereas in the other one, we've got a dot and a cross, which means that they're not. They're represented differently, so they're different angles. The next row down, we have another set of angles. You can see there that these guys start on one side, and then there's one on the other, and then what we call these guys are alternate angles. These guys are alternate angles because they alternate across the transversal line. Thing to think about with these ones as well, if the lines are parallel, as you can see in those diagrams, in the non-parallel lines we've got a cross and a dot, meaning that they are different, and in the parallel lines we have two dots, meaning they are the same. So essentially what that means is that if the lines are parallel, if those lines are parallel, the angles will be equal. Okay, and that sort of matches up with a couple of other different types of angles, such as the vertically opposite ones that you can find in these types of lines as well. Now our third type of angle that we find ourselves dealing with in parallel lines are co-interior angles. Co-interior angles. So what that means is that they are inside, or they share a space inside of the parallel lines. And you can see there in our two examples, we've got the dot and the cross, they're inside on the same side as the transversal, and the A and the B on the other side, same thing. Okay, now what happens with co-interior angles, that they cooperate in the inside, so they cohabitate the inside of that space, is they are now what we call supplementary angles. Okay, which means that they have to add to 180 degrees, which is what you can see in our parallel lines part of the diagram. So what we say about co-interior angles is if the lines are parallel, that phrase again, if the lines are parallel, these angles are supplementary, meaning they sum to 180 degrees. So that's what we talked about before in our previous video. Supplementary angles add up to 180. Co-interior angles do the same thing. Now they are the three lots of angles that we deal with. In the next video, we're going to check out some examples of how these work. We're going to see now how the three different types of special angles, corresponding, alternate, and co-interior, help us determine if things are parallel or solve other problems in terms of parallel lines. So in our first example on our screen here, we can see that we have two sets of parallel lines. So these little arrows here, all right, these little arrows signify the lines are parallel. Okay, so whenever you see those little arrows on the lines, it is telling you that yes, definitely those lines are parallel. So that's what we've got in our two diagrams. Our first problem, we've got two pronumerals to find in each one. And our first one there, we've got 110 degrees, A degrees, and B degrees. Now, A and B are one of our special types of angle, which is the co-interior angle. So that's what we've got here first. We have co-interior angles. We have the co-interior angles, but we also have vertically opposite angles. And we can use that information as well. And we kind of need to do that. So we need to know all about our other angles as well. So we know that these guys here are vertically opposite. So the value of A equals 110 degrees because they are vertically opposite angles. And that's our reason for that particular problem. Now, the other part that we have there, we need to find B. Okay, so B is going to be 100 now, because they're co-interior angles, they have to add up to 180 degrees. So they're going to be 180 minus 110. And 180 minus 110, well, that's going to get us to 70. And that 70 degrees is the value of B. And the reason we're going to give for here is because co-interior angles are supplementary. All right. That's the first one done. Let's look at our next one. All right, so our second one there, we've got A and B again, but they're in a slightly different position there. But we also have vertically opposite angles again. That we can use. Or, alright, so that creates some co-interior angles again. But an actual easier way to look at this is that this angle here, it might be easy to highlight, this angle here and that angle there. They are one of our three special angles. They are corresponding angles. Okay, those two are corresponding angles. So they're in the same spot. They're in the same spot on our parallel lines. So we get started. B equals 69 degrees. Alright, and we give the reason is corresponding angles. And that's all we have to really do, corresponding angles. You can add in parallel lines, that's fine too. Sometimes it can help. So let's pop them in just so that we can see what that line looks like. Now, when we write parallel lines, we don't even necessarily have to write the words parallel lines. We can just use the two line symbol that I've put in there. All right, which is this one little here. So that's our symbol for parallel lines. Now to do A, well, look what we've got again. We've got supplementary angles happening just on their own. So A is going to be equal to 180 minus 69. In this case, we're going to have 101 as our answer. And our reason is just supplementary angles. Again, you can add in supplementary angles need to be 180. You can use angles on a straight line. However you want to explain it, just explain it using something that makes sense, like supplementary angles. Let's have a look at our next set of questions. Okay, this is our last set of questions here, and we're going to decide whether or not these pairs of lines are in fact parallel. So let's have a look at our first one here. We have 60 and 114. Now these two are supposed to be co-interior. Well, they are co-interior, but do they add up to the 180 that they need to add up to? So let's go 60 plus 114. So let's bring up our calculator. Okay, so we want 60. We want 60 plus 114, and that's 174. I'm sure you have managed to beat me to that answer. So what we can say there is that even though they are co-interior angles, they do not meet the requirements. Alright, so no, they are not parallel. Okay, so our requirements are to sum to 180 degrees. They are not parallel. Okay, so that's our first pair out of the way. Our second pair, we have corresponding angles. We have corresponding angles. So they're in the same position on our lines. Okay, so that's one of the three. We have 79 and 82. Does 79 equal 82? Well, no, it doesn't. So again, we're not meeting those requirements. So these guys are not parallel. Okay, our last set of questions. Now we have alternate angles. Okay, so these guys are alternate angles. I'll just get the calculator out of the way again. Alternate angles need to be equal to each other as well. We've got 125 and 125. Are these guys equal? Well, yes they are. Therefore, these guys do meet the requirements. Therefore, they are parallel. And there's parallel lines for you. So these are the three things that we look at for parallel lines. Hopefully this video has been informative. Hope it's helped you. Good luck with your questions, and thank you for watching.